Welcome to Educator.com. In previous lessons, we learned about simplifying radical expressions and performing operations with radical expressions. Today, we're going to apply those techniques to actually solve radical equations. First of all, defining a radical equation. A radical equation is an equation that contains radicals with variables in the radicands. So, if you are talking about an equation such as this does have a variable in the radicand, so it's a radical equation. Same with 3 times x to the third minus 2 equals 4x. Okay? However, if you're talking about something like this, that's different. That does not actually contain a variable in the radicand. So what we're talking about today are equations of this type, where there are actually variables as part of the radicand. In order to solve these, there's a two-step process. The first step is to isolate the radical on one side of the equation. By the radical, I mean the radical that has a variable in the radicand. There may be other radicals, such as radical 3 or square root of 7. But when I say isolate the radical, it means the radical containing the variable. Then square both sides of the equation and solve. Let's look at an example. The square root of x plus 3 minus 10 equals -1. So pretty simple. Step 1, isolate the radical. And have the radical right here, but I also have a -10. So I'm going to need to add 10 to both sides. And that gives me square root of x plus 3 equals 9. Next step, square both sides. Radical times itself is the radicand, so that gives me x plus 3, because it's radical x plus 3 times radical x plus 3. 9 squared is 81. Solve for x by subtracting 3 from both sides, and I get x equals 78. So first step, isolate the radical on one side of the equation. Step 2, square both sides of the equation, and then go ahead and solve for x as usual. There is one big difference between solving radical equations and solving other types of equations that we've discussed, and that is that you might come up with what's called an extraneous solution. Extraneous means sort of like extra. So an extra solution, and the thing about extraneous solutions is these are solutions obtained using the method we just discussed that do not satisfy the original equation. So let's talk about the example we just discussed. I started out with this equation. I then rewrote it in this form, and that is not the step that creates an extraneous solution. This step is fine. It's the step in which you square both sides. Squaring both sides can actually create extra or extraneous solutions. So this doesn't always happen, but it can happen, and it's because of this step right here. Because of that, you need to check all solutions in the original equation. Now, a few things can happen. You can check this and find out that you have a valid solution. It checks out in the original equation. Another thing that can happen is you might check it out and it is not a valid solution. It's a solution for this new equation we created here, but it is not a valid solution for the original equation that we were trying to solve. You may also have multiple solutions, and some of them may check out and some don't. Now, the solutions for this original equation, if there are any, if there are any valid solutions for the original, they will show up down here, but there may be extra ones as well. So the solutions to the original equations will be among the solution for this new equation, but they might be buried among some extras. It's also possible, as always, that there is no solution to the original equation. So that could occur. I could have two solutions down here and I could check them and neither is valid. So I might have one, I might have two, I might have none. So let's go ahead and check this out. I found that x equals 78. So I need to check in this original equation, or at least I could check it in here as well, actually, as long as I do it in the step before I've done the squaring. So let's go ahead and use this. This looks simpler. Then I don't have to do that extra step. Okay, so I'm going to go ahead and say x equals 78, because that's the solution I'm checking. So this is the square root of 81 equals 9, and that is true. The square root of 81 is 9, and 9 equals 9, so this is valid. That means that x equals 78 is a valid solution to my original equation, not just a valid solution to my created equation. So it's extremely important to check your answers. Previously, it's always a good idea to check your solutions back in the original equation, but here it's mandatory. Otherwise, you have no way of knowing if the solution you have is a valid one or an extraneous one. Okay, so let's look at the first example. The square root of 3x plus 12 equals 2 radical 2. First step, isolate the radical. Now, I have a radical over here, but that's not the radical I'm talking about. Again, the radical I'm talking about is the radical with the variable in it. So let's go ahead and look at that, what we have. And what we need to do now is square both sides. So first, isolate the radical. Done. So then we're going to square both sides of the equation. Okay. I'm going to square this. And I need to do the same thing to both sides. I have a radical squared. That's going to give me the radicand. 3x plus 12 equals 2 times 2 is 4 times the square root of 2 squared. So this is going to give me 3x plus 12 equals 4 times 2, or 3x plus 12 equals 8. Go ahead and subtract 12 from both sides to yield 8 minus 12, or negative 4. Isolate the x by dividing 3 from both sides to get negative 4/3. Third is check the solution in the original equation. Or you can check it in a bit of a later step, but it has to be before you've done the squaring. Okay, so I have x equals minus 4/3. I'm going to go ahead and insert that into the original equation. 3x, so 3 minus 4/3 plus 12 equals 2 radical 2. So this is the square root of 3 times negative 4, that's negative 12 over 3 plus 12 equals 2 radical 2. Negative 12 divided by 3 gives a negative 4 plus 12, or 8 radical 8 equals 2 radical 2. Come up here, and we can simplify this. This is 4 times 2, that's a perfect square. Go ahead and pull out the square root of 4. And what I found is that when I substituted x equals negative 4/3 in here, then I ended up with a valid solution. I end up with a valid equation. 2 radical 2 does equal 2 radical 2. So this is valid. So x equals negative 4/3 is a valid solution to the original equation. Okay, I have a second example here, and again, I look at it and the radical is already isolated. The radical containing the variable is already isolated. So I'm just going to go ahead to my second step, which is to square both sides. So that's x squared equals square root of x plus 12 squared. Okay, that gives me x squared equals x plus 12. So what I have is a quadratic equation. I'm going to go ahead and put this in standard form to get x squared, subtract x from both sides, minus x, subtract 12 from both sides. This equals 0. Now I'm going to solve this by factoring. This is pretty easy to factor. And when I have a negative in front of this term and in front of the last term, what that tells me is, since I have a negative here, this must be the product of a positive number and a negative number, because a positive times a negative gives me a negative. Looking at the factors of 12, I have 2 times 6. I also have 3 times 4. Okay. What I need is for these factors to add up to a negative 1. If I make one of them a positive and the other a negative, I need them to add up to negative 1 in order to satisfy this equation. Well, if I take 2 minus 6, that's going to give me negative 4. If I take 6 minus 2, it's positive 4. That won't work. It must be these. So I try making 3 a positive and 4 a negative. 3 minus 4 equals 1. And 3 times is negative 1. And 3 times negative 4 equals negative 12. So that satisfies this equation, the factoring. So I'm going to go ahead and factor this to x plus 3 times x minus 4 equals 0. Now I'm going to use the zero product property to solve. I'm going to set each part of the product equal to 0. And then I'm going to solve. And what this gives me is x equals negative 3 and x equals 4. So I have 2 solutions. After I come up with the solutions, I need to check. So here I'm going to go ahead and check the solutions. Okay, I'm going to go ahead and check x equals negative 3 first, and I'm going to do that in this original equation. X equals the square root of x plus 12. So if x equals negative 3, that means negative 3 equals the square root of negative 3 plus 12. Negative 3 equals the square root of 9. Now, recall that when we have a radical, what we're saying is we want the principal or positive square root. So the principal square root of 9 is 3. Well, negative 3 does not equal 3. Therefore, this is not valid. The solution is not valid. So the problem occurs in the step where you square. And that created this solution of negative 3, which is a solution to this new equation, but it's not a solution to the original. Let me go ahead and try x equals 4. So I'm going to check x equals 4. So that's going to give me 4 equals the square root of 4 plus 12. So 4 equals square root of 16. The square root of 16, the principal square root, is 4. This is true. This is a true statement. 4 does equal 4. So this second solution is valid. Therefore, x equals 4 is my only valid solution for this first equation. And I have another extraneous solution, and I have one real solution. Okay. In my next example, I have an equation with a radical in it, but the radical is not isolated. So my first step is going to be to subtract 5 from both sides in order to isolate that. I can simplify right here and then proceed. So now I have my radical isolated on the left. Next step is to square both sides. And I see what I have here is, let's see, 2x minus 3, so that's squared, x minus 3 squared. So on this left side, I just take the radicand, 2x minus 3. Here I have the square of a difference. So I have x minus 3 squared. Remember, a minus b squared, square of a difference, equals a squared minus 2ab plus b squared. So that makes things faster. Here, in this situation, a equals 1 and b equaled 3, negative 3. Okay, so I'm going to go ahead and write this out as x squared, because that's a squared, actually a equals x. Okay, and then minus 2ab, which is going to give me minus 6x plus b squared. So I end up with 2x minus 3 equals x squared minus 6x plus 9. Simplify this. So let's subtract 2x from both sides. That's going to give me negative 3 equals x squared minus 8x, so subtracted 2x from both sides, plus 9. Add 3 to both sides. Okay, I'm going to go ahead and rewrite this with the expression, the trinomial on the left, and the 0 on the right. More in a standard form. Next thing I need to do is solve. So I've gotten rid of the radical. So now I'm just solving this for this trinomial. I need to solve for x. This actually is fairly easy to factor out, so solving by factoring would be a good way to go. And I see that I have a negative for the second term and a positive over here, positive 12. What this tells me is that I have x minus a term times x plus a term, because, minus both negatives, because the product of these two negatives is a positive, but their sum comes out to be a negative. So what I have is a negative and a negative. So I look at 12 and the factors, and I have a bunch of possibilities. I have 1 and 12, I have 2 and 6, and I have 3 and 4. And I need ones that sum up to negative 8x. Well, minus 1 and minus 12, that's going to be negative 13. Minus 2 plus minus 6, that's going to be negative 8. So negative 2 times negative 6, because these are both going to be negative, is 12. And negative 2 plus negative 6 is going to be negative 8x. So I know I factored correctly. Using the zero product property, I'm going to go ahead and solve. For x minus 6 equals 0, I'm going to get x equals 6. For x minus 2 equals 0, I'm going to get x equals 2. Okay, now I need to check the solutions. I'm going to go ahead and check it using this. I haven't squared yet, so that's perfectly fine. So I'm going to let x equals 6. The square root of 2x minus 3 equals x minus 3. So let's check that. The square root of 2 times 6 minus 3 equals 6 minus 3. Let's see if that checks out. This is 12 minus 3 equals 3. Square root of 9 equals 3. And that comes out to 3 equals 3. This is valid. So x equals 6 is valid. Now, if I let x equal 2 and I do the same thing. I'm going to go ahead and substitute in to this equation. 2 times 2 minus 3 equals 2 minus 3. That's going to be the square root of 4 minus 3 equals negative 1. Okay. And that's going to give me the square root of 1 equals negative 1. And that is false because the radical 1 is 1. It's the principal square root. That does not equal negative 1. So this does not check out. This is not valid. So I have one valid solution, and my valid solution is that x equals 6. That's why it's absolutely crucial to check both solutions back in the original equation when you're working with radical equations. Okay, in this example, we have a radical expression, and the radical is not yet isolated. First step is to subtract x from both sides. Now that the radical is isolated, square both sides. Okay, negative 1 times negative 1 is going to give me positive 1. So I'm going to go ahead and eliminate that 1 and then take the radicand. 4 minus 16x equals, I'm going to rewrite this slightly differently, negative x plus 4 squared. If you multiply that out, there's a couple ways you can do this, but let's go ahead and multiply it out using FOIL. First terms, negative x squared is x squared. Outer is minus 4x. Inner terms, minus 4x. Last terms, 16. So this is going to be x squared minus 8x plus 16. No x right there, just plus 16. So this is 4 minus 16x equals x squared minus 8x plus 16. Now I just need to solve. So let's simplify by combining some like terms. Subtract 4 from both sides. 16x equals x squared minus 8x. 16 minus 4 is 12. So I have a negative 16x. Add 16x to both sides. This is 0 equals x squared. 16x minus 8x is plus 8x plus 12. So now I have a trinomial that's pretty easy to factor out. So let's solve this by factoring. 0 equals, I have positives here. So it's going to be x plus the other factor times x plus the other factor. Factors of 12. Well, I have 12 times 1. But the sum of those two needs to be 8. And so it's not correct. 12 plus 1 is 13. Second set of factors for 12 is 6 and 2. 6 times 2 is 12, and 6 plus 2 is 8. So that satisfies this equation. So x plus 2 times x plus 6. And you can always check this yourself by multiplying out and making sure you get back that trinomial. So now I'm going to use the zero product property. X plus 2 equals 0. X plus 6 equals 0. This is going to give me x equals negative 2 and x equals negative 6. So I have two solutions, and I need to go check these back in the original equation. Okay, so the original equation up here, I'm going to first check x equals negative 2. So that's going to give me negative 2 minus the square root of 4 minus 16 times negative 2 equals 4. So that's negative 2 minus the square root of 4 minus negative 16, minus 16 times negative 2. 16 times 2 is 32, so this is negative 32. 16 times negative 2 equals 4. Continue to simplify. A negative times a negative gives me a positive. which is good because then this works out to 4 plus 32, which is a nice perfect square. I go ahead and take that square root, which is 6. So negative 2 minus 6 is negative 8. Negative 8 does not equal 4. So when I substituted a negative 2 here, this solution did not check out. This is not valid. I need to check my second solution. And that second solution is negative 6. So I'm going to go ahead and try that. Negative 6 minus the square root of 4 minus 16 times negative 6 equals 4. Okay, so that's going to give me negative 6, the square root of 16 times negative 6 is 96. I'll go ahead and combine a couple steps here. So 16 times negative 6 is negative 96. Then, but this is a negative outside, so that negative times the negative becomes positive 96 equals 4. So this is negative 6 minus the square root of 100 equals 4, or negative 6, the square root of 100 is 10, minus 10 equals 4. Negative 6 minus 10 equals negative 16, and that does not equal 4. So that is also not a valid solution. So here the solution is just the empty set. There is no solution. There are no real solutions to this equation. And I came up with two solutions by solving this by my usual methods. But those turned out to both be extraneous solutions, as neither one of them checked out in this original equation. Today on Educator.com, we learned about how to solve radical equations, and I will see you again for the next lesson.